So welcome to the second talk. It's really a kind of a production almost. So I'm really happy that we have the opportunity to, after the first talk where Dirk introduced the issues with the exponential growth, we also were already alluding to ideas to resolve that and to maybe help us to get our hands around that. So it's a pleasure to have him to talk about the planetary nervous system, which I think is a tremendously original idea and can help us a lot to get a better understanding. So let's welcome him again to the second talk.
Yeah, thank you very much. If you find anything noteworthy, there is a hashtag and you can tweet about this too. And so today I'm talking about the planetary nervous system and how we can create it together. Now, when we want to understand the future of information system, then it's good to look into the past. And I went to this famous computer history museum in the Silicon Valley. And you can basically look back into what happened and how. And you can see in particular this quotation by Alan Kay that says, the best way to predict the future is to invent it. So this is basically our task. It all started with computers. In fact, a few computers. IBM chief Watson at that time thought there would be a world market for maybe 5 computers. It was not very accurate. And one of the reasons is that eventually computers were networked with each other, and it started off with ARPANET, a military communication network between a few computers. But eventually communication between computers was opened up also for civilian use. The internet was established, and that opened up all these fantastic opportunities that we have today. Then came Tim Berners-Lee, and at that time he was working at CERN. He wanted to establish the HTTP protocol that links different web pages, and that created the World Wide Web. In fact, that opened up the internet for non-experts. And as a result, you can go shopping today in the internet. And so, for example, there's eBay, there's Amazon. But the next step then was to come up with social networks. And we all became part of this global information system. We are both producers of data and processors of data. Yeah, in a sense, there are computer chips and there are humans. And the next step in this evolution is that we have smart wearables, and that we have an Internet of Things that's now growing, and it's connecting the internet with more things like computers, smartphones, smart watches, and other devices, machines also. More of these things than humans. And in about 10 years' time, there will be 150 billion things connected to the internet. It's just amazing. So the internet reaches out more and more, and everything becomes part of the internet. It becomes an internet of everything. Information systems get ever more ubiquitous and pervasive and intelligent, and they're driving a digital revolution. We need to be aware of this. What does it mean? It means in particular that computers will eventually be more intelligent than humans. And it may take just about 10 years of time. Yeah, some people think it might be 25, others think it might be less than 10 years. In fact, computers can already do many tasks that humans used to do better than humans, but each single task. And now kind of the next challenge is to bring it all together. So what does the digital revolution really mean? because I believe it's going to change the economy, it's going to change our society, and we better understand what's going on there. What are the trends, what are the driving forces, and can we use these forces to our advantage? So ICT becomes pervasive, borders dissolve, there's instant availability, we see more automation, a second machine age, as people say. We see extreme speed. Most of our knowledge is probably outdated. We can't learn quickly enough because the world is changing. It still looks pretty much similar, but as the way of interaction between the system components is changing, the world changes too. As complexity scientists, you know this very well. We have more variability, less predictability, probably also less controllability, more connectivity, more complexity, more data. We can actually duplicate data as often as we like. So immaterial resources will become more important, ideas will become more important. We will see that data will be cheap, open data will spread, it will also be very important. Money will be mainly created by transforming data into useful information and knowledge. We may get into a situation where there are almost no secrets. We'll see individualization, extreme diversity, personalization, user centricity, real-time feedback, self-organizing systems, wisdom of crowds. Young people may be as informed as experts, or sometimes even better, so hierarchies might flatten out, may have more participation, that's what I believe. An increasing power of ideas, ethics therefore also becomes more important, and science fiction is becoming real. And those countries that will adapt to these principles first will be leading on the others. Bad luck. Yeah. So we need to prepare ourselves for the digital revolution to come. And we have seen that already many years back, computers have been the best chess players, and they will soon be not only better pilots, because most planes are most of the time already controlled by computers, but also better drivers. Think of Google's self-driving car, and other automobile companies will offer them too. So then the question is, what else will be happening? In fact, computers are already better than the best players in favorite game shows. We're talking here about IBM Watson. They're now advising also telephone hotlines, doctors. So what are the jobs that will be left for humans? That is a serious question that we need to ask, because we're entering a situation where there's too much data, too much speed, too much connectivity, and too much intelligence for us. We're exposed to a big data tsunami. And the question is how to survive this tsunami. Because, it's a serious thing. On May 6, 2010, there was a flash crash, and it evaporated basically $600 billion within just 20 minutes. Now suppose that would have been a Friday afternoon just at closing time. That might have been the end of the financial system. In any way, this is faster than people can respond. And in the beginning, people thought, oh, that was probably a criminal act or an error, so-called fat finger. You entered billions rather than millions or something like this. But it turned out nothing of that was true. It was just one of these cascade effects that I was talking about in my previous talk. Because of automated algorithmic trading, a small trigger could trigger off a cascade of sales of other stocks and derivatives, and it caused this sudden drop. And that was not the only one. Yeah? There are by now dozens of them. Not always that dramatic. So I do think that information and communication technology, we may like this or not, will transform science, society, economy, and all our current institutions. So, for example, also the way we educate. We now see MOOCs, for example, these massive open online courses. I believe we're heading towards personalized education. The way we do research, suddenly there's a fourth pillar of science, big data analytics. And as I said, Chris Anderson thinks even that's going to replace all the other pillars, so no need for science in the classical sense anymore. I was critical about this. The way we move, like with school cars, the way we transport goods, like with drones, the way we go shopping already for some time, because we use Amazon or eBay or some other portals, and the way we produce with 3D printers, the way politics works with probably more citizen engagement, and the entire economy. What we see now is a makers community, emerging sharing economy, prosumers, co-producing consumers, and so on. The financial business, once the domain of bankers, is now increasingly replaced by algorithmic trading, PayPal, Bitcoins, Google Wallet, and you name it. And the biggest share of the insurance business is now in financial products such as credit default swaps. And finally, also, wars, conventional wars might be replaced by cyber wars, and actually they're discussed on the same level as nuclear wars. So every single institution of our society, maybe with the exception of religion, will change, but maybe even religion too. So this is just too much for many companies, and Kodak was one of these companies that went bankrupt, even though Kodak owned most of all digital camera patents. But they couldn't transform themselves into this modern digital camera company quickly enough. That was the end. So what other companies will be dying? Now this is how car manufacturing looks today. Can you see any workers here? No humans around anymore. It's mostly done by robots. And as a result, cities like Detroit, that used to be the big car manufacturing capitals, are in a really devastating state. So we are faced with major economic changes, and this is reflected also in the employment numbers. 1850, there were about 70% of people working in the agricultural sector. Then with the invention of the steam engine, industrialization came up. Many things were produced more efficiently, and a lot of jobs were lost in the agricultural sector. Some jobs were created in the industrial sector. As you know, it produced social and political unrest and many other problems. Eventually, however, the empty jobs were replaced, in particular also by the introduction of another sector, which is the service sector. Now, what happens now is the following: a fourth economic sector is emerging. And as all the other transitions before, this will be challenging our current system, and we need to prepare for this well. Because in about 20 years' time, 50% of industrial jobs will get lost. And we have, say, 3 to 5% of agriculture jobs, plus 7.5 to 10% in industry. Plus, half of the service sector jobs will be lost, which will be around 30%. That means if we add up the numbers for all the classical three sectors, agriculture, industry, and service, this is less than 50%. Which means that we have to produce 50% new jobs, and so far in the information and knowledge production sector, there are just a few percent. So this will be a great challenge, a really big challenge, because if you talk to people in the Silicon Valley and in the IT industry, they would say, that's, most processes, everything that are routine jobs, everything that is procedural, one day it will be done by computers, much more cheaply, or by robots. Will be large companies that do it for entire regions or even countries. So the question is, are we still needed? And to be pretty clear about it, will not be needed to produce all these services and products that we have today. Just a few of us. Even lawyers, even scientists, even medical experts, a lot of this can be automated. So there are two scenarios. Either this one scenario where with that computers and robots do our work, but then there are very few companies and very few multi-billionaires or trillionaires who will produce all this, and a lot of unemployed people. Or we'll have to come up with a completely different kind of system in which we create new opportunities for new products and services and jobs, and that is the participatory market society that I'm going to talk about. In fact, in some countries we are already seeing the devastating power of this digital revolution. In some countries, more than 50% of young people are unemployed with no signs of improvement. So it's important that we understand the new principles of the economy 4.0, which is, agriculture is 1.0, industry 2.0, service 3.0, digital 4.0. So a lot of automation of procedural and routine jobs. Instead, information and knowledge production. We will need personalized products, and that will produce hyper variety markets. So basically every one of us will buy products and services just shaped for us, a personal product. Creative jobs, therefore, will be more important. I also believe network thinking, this other regarding thinking that I mentioned at the end of my last talk, will become important. That means if you want to be successful, you need to engage in a relationship with your supplier and your customers. Yeah? You need to know what they really want. You need to turn them into a partner. If you just optimize your own small company or big company and don't care about suppliers and customers, you won't survive, because your competitor that is interested perhaps in customers and suppliers will provide better services. So that brings us, together with the network thinking that is necessary here, into a sharing economy where competition is not the only thing. In fact, there will be mixtures of cooperation and competition. And understanding how this works exactly is actually one of the scientific challenges. Co-learning, co-innovation, co-creation, these are important keywords. So for that reason, we'll have to build an information, innovation, and production ecosystem. Of course, now what I produce might be input for what you produce. What you produce might be input for what he produces, and so on. And the more we share, the more possibilities become possible, and the more business and services will be created. And that means we'll all be prosumers, not just consumers. We will be co-producing consumers. There will be more peer-to-peer business. I will be involved maybe even in energy production, in software production, in production of transportation services, or also accommodation services, and whatever comes to mind. I'll have more home production with 3D printers, and altogether more bottom-up participation. In the best of these two societies I have been describing, right? There will be new forms of work, and we see that already through Odesk or Amazon Mechanical Turk. Some people just pick up a job for a few minutes and get $1 or so, and then pick another job. So the lifetime commitment that we had maybe 20 years ago in some companies, it's replaced by minute commitments. It's certainly not always, but this is a shocking development. So we need to have completely different kinds of job markets and social benefit systems to deal with these kinds of situations. We need a job platform that helps us to organize all this seamlessly. They have short-term commitments, as I said, and projects. So not always do we need to establish an entire company. Companies are slow. They're not very flexible in many cases. So we need to have more flexible forms of organizations, and these are projects. Right? And in order to be able to produce complicated and complex services and products, we will have to come up with a modular organization, and it will be important that we have interoperability between these different activities, because otherwise it's not going to come together. But altogether we see that there is a trend towards more decentralization, towards distributed systems and self-organizing systems. So I think by now we understand we're going to see a completely different economy and a completely different society, and I think it's important that we realize that this can be an opportunity for all of us, including the state and the government. Future information systems are not just a thread. If we use them in the right way, we can manage these challenges better, and we can actually create a lot of jobs with them. But we need to think about how to do this. And one of the elements that might become more important is citizen science, participatory, distributed way of science, and this allows us to create more bandwidth. Right? More speed too. And altogether we should maybe compare this with this array of astronomical antennas. We're using them because they are more powerful than a single big antenna. And if we transfer that to society, then basically we can say that if many of us together can create products and services and intelligence that is much better than what a single person or a single company or a supercomputer can do. But for this, we need to learn how to network our ideas with each other to create these benefits. And this is the way we can explore the universe and our Earth much better. So why is participation so important? Because it produces more capacity and bandwidth, more creativity becomes possible, better solutions by empowerment, more efficiency by distributed control, more resilience by modularity, better management of complex systems by more autonomy, more jobs by personalization and creation of hyper-variety markets, more success by trust, more social well-being, economic prosperity, societal resilience, collective intelligence, individual happiness, cultural development by diversity. I mean, diversity is a major factor and a major driving force of innovation of all these different important properties. Now, on the other hand, more diversity is challenging. Yeah, we have already quite enough trouble with the diversity that we face in this world of today. And so we need social information technology to help us master this diversity and guide us through this complexity. But we've seen that if we have the right designs, then this can create actually very powerful systems, such as the Wikipedia knowledge base. That is knowledge created by a lot of people, and in many cases better than the best encyclopedia out there. Now the question is, why would we have more participation in the future, apart from its favorable aspects? There are some factors that support it and drive it, like good education, access to high quality information, through decision support systems and services, the emergence of coordination platforms such as social media, the spreading of reputation systems that promote accountable and responsible behavior, and the consideration of externalities. And these factors are currently on the rise with the spreading of open data, citizen science, recommender systems, with moderated internet communities, the maker movement, the Internet of Things, and other stuff. And further game changers are the increase in variability, complexity, and diversity. OpenStreetMap is another powerful example, right? This is a community-based service. 1.5 million volunteers are actually creating this most up-to-date information system about all the streets and trails in the world. If there's a new street or a street has been closed down, that will be very quickly adapted. If there was a disaster, this information will be collected by people like the crisis mapper community, and it will bring together a lot of information in a short time, and no company and no government could do that by itself. So participation is a powerful principle. Now, I'm aware that governments are sometimes afraid of more participation, and therefore it's important to point out that it doesn't necessarily mean social chaos. And I want to critically analyze the Twitter revolutions to illustrate that it's a misunderstanding that these were revolutions caused by social media. In my previous talk, moreover, I've shown you that decentralized mechanisms, such reputation systems, can promote social order and cooperation. If we just have the right mechanisms in place, things will work well. So it's often claimed the Arab Spring revolutions were Twitter revolutions. But I personally don't believe this. And why? Because there is a dependency of the form of organization of a country, and the GDP per capita. Fertility matters too, to a certain extent. I mean, number of children per family, but in principle, there is a tendency of a separating line here, and it means that if a country eventually is economically more and more successful, the GDP per capita would go up, and as a result, the entrepreneurs would need more decision freedoms in order to run their companies successfully, and so eventually that drives this system over this line, and it would mean that the country would become more democratic. And we have seen these transitions not just in the Arab countries, but in Europe too. And that was just a few decades earlier, and sometimes you can go above the line for some time, but then it takes just a trigger, like in this super-cooled fluid, to cause this transition. And so the question is, what was the trigger in the case of the Arab Spring? And it turns out it was food prices. You can see political protests were by far the strongest when food prices reached such a high level that many people just couldn't afford their daily food anymore. So nothing to do with Twitter revolution, yeah, with social media. It's just they didn't have enough food. And so that is basically the story behind the Arab Spring. And now let's go back to the digital revolution. If we don't want this to become a social or political revolution, we need to prepare well, right? So we need public institutions investment for the digital society, including open data to allow for participatory activity on the economy and society, and open innovation too. Otherwise, we cannot compensate for the gap in the job market. I don't see a way. So it's helpful to look into what it required to make the industry age a big success, the age of the automobile, for example. And of course, industry takes more than this, but it's a good example, I would say. So first of all, we needed to learn how to assemble cars, and we also needed to learn how to do mass production to make it good that everyone could afford. We needed to build streets. We needed to come up with petrol, and for this we needed to learn how to refine crude oil. We needed gas stations, parking lots, driving schools, driver licenses, speed limits, and many other things actually, in order to make sure that the age of automobile would be a great success. Similarly, we're investing billions into agriculture. There's a lot of subsidies in Europe, I know, or has been at least, and we're investing a lot into service society too, in particular public schools, public universities, public libraries, and so on. So that means we would need public infrastructure and institutions for the digital society too. And the question is, what kind of infrastructure would it be? So I believe what we need is global, trustworthy, transparent, open, participatory ICT platforms. I already mentioned social information technologies. I will now focus more on this Internet of Things. I believe we should build it as a citizen web, should build intelligent level on top of it, which we could call the planetary nervous system. We need a technology to managed personal data, global participatory platforms, reputation systems, but pluralistic ones, micropayment systems, innovation accelerator, interactive virtual worlds, to mention just a few. And with this, I'm turning to the Internet of Things, which is the now emerging big technology after big data, I would think. And it has revolutionary potentials. I really think this is the enabling technology for the 21st century. And the areas of application include real-time measurement, the development of global system science that would extract the interdependencies and the laws of our society and economy and help us to manage our world more successfully. Greater awareness of chances and risks to support everyone's decision making. Possibilities to create self-organizing systems, and finally opportunities to create collective intelligence. So that's a lot. That's a lot that we can do with the Internet of Things. And here are some examples. How do we create more awareness to support better decisions, effective actions, and more responsible behavior? Well, certainly we would need to create maps of our world. These maps would inform us to take better decisions. Like we could create compasses for decision makers. And here's just a movie that's illustrating how we could bring information together that's already on the web. So these are many positions of photographers that have taken hundreds or thousands of photographs. And as you can see, you can put them together at home and reconstruct a building like the Colosseum in 3D. And you can do that of any place in the world that people take pictures of. So from home, you can take all the world into your living room. We can map environmental change and who causes it. We can map resources and who uses them. And we could also measure externalities, because this is very important to reduce damage of our economy, of our environment, but also of other systems, including our society, and what is part of it is kind of social capital, like trust, reputation, cooperation, and so on. So if we would charge for these externalities, we could counter damage that is currently created. And in this way, as I will show you later, we would be able to make the invisible hand work. In fact, this idea of the invisible hand that would magically coordinate all the processes in the world, in our society, is 300 years old. The fable of bees basically described this dream that our society could work like a beehive. And the beehive is so perfectly organized, it's really surprising. And there is a queen bee, but it doesn't give commands to all the other bees. It just lays eggs, that's it. So this is all very surprising. And therefore the idea came up, okay, if we just all did the thing that we can do best, that would create the greatest advantage to our economy and to our society. And basically that created this commandment, you should do what's best for you. And as we know, it doesn't always work well. We have to look into this a little bit more carefully. But sometimes now coordination in our society works impressively and produces beautiful outcomes. Yes, and of course Adam Smith is one of these famous people who is known for this principle of the invisible hand. And what I'm claiming is that with the technology of the Internet of Things, we can now make the invisible hand work. With 300 years after its invention, it's now possible to do this. And I'm giving you here an example for the case of traffic light control. Now, the problem of traffic light control is there are so many things that you can vary, like the order of the traffic lights, the period of the green time, the time shift between this intersection and that intersection, and so on. So, in a even medium-sized city, it's not possible to do this optimization in real time. There are just too many possibilities. It's an NP-hard optimization problem. So, what do you do? Well, intelligent people came up with this idea that you could run each intersection in a cyclic way, and then you would have to synchronize the cycles, and that's it. You know? And in fact, what you do is you measure basically how traffic changes in the course of the day and the week, and then you average over Monday mornings, 10 o'clock, and Friday evening, 4 o'clock, and so on. And for each of these time windows, you create optimal traffic light controls offline. And you apply it at that time of the day and the week. And you could also then measure the actual traffic flows, because there's a lot of deviation from the average typical course. In fact, the variability is as big as the average. And so you would extend or shorten green times, but you would stay within this cycle. Still not good enough. It's not good enough because the variability of the flow turning right, going straight, or whatever, is 100% approximately. So you have an optimal control for a situation that never occurs in reality. And that's why I started to say, why don't we come with a traffic light control which is, first of all, flexible? If you cannot predict the situation, then you should be able to respond flexibly to the situation, means to the real local needs. Yes, and so we looked into these three possibilities: an optimal top-down attempt, control attempt, like a benevolent dictator that would collect information from all over the city and then try to come up with an optimal outcome, which I said is still unfortunately not optimal, and then implement that like a benevolent dictator. So control all the traffic lights. Number two is the Homo economicus. In this case, each single intersection is separately minimizing the travel times of all the vehicles that are approaching this intersection. I mean, each intersection strictly does the optimal thing in terms of travel times of that intersection. Yeah? Every intersection does the best. So that's kind of the principle of the Homo economicus, and that's what the standard economic model would demand. And this is a similar approach, but with one difference. If one of the queues grows large and beyond a certain, what we call critical limit, it would first be cleared before we go back to the travel time minimization. So it doesn't strictly minimize travel times. We'll see, however, that it will nevertheless altogether on average reduce travel times. So what does top-down regulation do? Well, what you see is if capacity utilization goes up, the queue length of vehicles goes up too. I mean, no surprise. Yeah? But let's see how the principle of the Homo economicus, the selfish local optimization does. And in fact, it's much better, much shorter queue lengths. And the surprise, however, is that suddenly, long before the full capacity utilization, the queue length explodes. So we can say two things. Here, Adam Smith's principle of the invisible hand works up to this point. Yeah? So we have a self-organized coordination and very efficient. But if we push the system too far, if we demand too much from it, the coordination principle breaks down. So it fails here. And then suddenly this traffic control center, the benevolent dictator says, fortunately you have me, because I'm making sure that we can still operate the system here at these high capacity utilizations during the rush hour. That's true. Surprisingly, however, there is even a better solution. And this better solution is the one where we have this other regarding optimization. It means where each intersection takes care of not producing queues that reach up to the next intersection, because that would create spillover effects. And these spillover effects would create so many disturbances that it would create a massive congestion in a large area of town.
May I just have a question? So, what do you refer to the Adam Smith principle? Because is that just like selfish behavior in your interpretation? Because I would argue that also it's another regarding optimization process.
This is just local optimization without taking care of your neighbors.
Right, but then you suggest that the Adam Smith, the invisible hand. So what kind of like an optimization principle lays behind that? In the previous slide, I guess you had that.
This curve relates to a minimization of travel times of all the vehicles heading towards a certain intersection.
Based on self-maximization.
Yes.
And that's Adam Smith. Basically.
Yeah. And that works well here, that fails over there. While the difference here with this other regarding optimization is that we interrupt the minimization of travel times if there's a long queue, and we would first clear this long queue before we go back to the minimization of travel times. Why is this important, and why is this other regarding? Because we don't let this queue go up to the next intersection where it would disturb the traffic flow at that intersection. We would say, okay, why should I, as this intersection, care about my neighboring intersection? But the point is, there's so much disturbance that is caused by long queues that it would mess up the entire traffic system in this area. And so, having a little bit slower service avoids disruption in neighboring intersections, and so on average cars are faster. Yeah? So in principle what we can say is that this is also a local optimization, but it takes into account the externalities. Yeah? And that's a major insight, because what I'm saying is if you take into account externalities, then you can make the invisible hand work based on local optimization. That's this difference. Taking into account externalities is the main point. And in fact, what you get is beautiful green waves and improvements for all modes of transport, like individualized traffic, public transport, pedestrians and cyclists, and it makes also travel times more predictable, and it's good for the environment too. So rather than having a top-down control of traffic through the traffic lights, we now have traffic flows that bottom-up control the traffic lights. Yeah? A completely different principle. Now, the question is, could we also use this to improve the efficiency of economic and social processes? And my claim is yes. Oh, that's what we had already, sorry. And in fact, there's this Nobel Prize winner, Elinor Ostrom. She made studies in Switzerland, by the way, of communities that governed themselves. That they had so-called common goods, public goods, and usually economists assume that they will end up in a tragedy of the commons. But what Elinor Ostrom showed was that there exist a number of rules. If you apply these kind of rules, then a self-governance would work, and it would be efficient. And that's kind of logical to a complexity scientist. Now, if you have the right kind of rules, the system would self-organize and produce a functionality that you would want to have. If you have the wrong set of rules, the system would also self-organize, but it would create an undesirable outcome. So everything depends on the set of rules, on the interactions. Now, the question is, how can we make the interactions more favorable in terms of their outcomes? Yeah? And so I came up with a patent on social information technologies, and it basically looks into 4 kinds of situations. So we assume interactions of 2 people or 2 companies or a company in the environment, whatever, and it could be a lose-lose situation where the interaction is bad for both sides. Yeah? So what should we do? Well, better avoid that situation. Then there could be a win-lose situation. That means the interaction would be good for one side, but bad for the other side. Now, if it's altogether bad, it means it causes a deterioration, then we need to basically protect the potentially losing side from exploitation. Of course, the winning side would like to engage into this interaction, but it would be bad for the other side and bad altogether. But it could also be a situation where it's good for one side, but bad for the other. Altogether, however, it would create a benefit. So what should we do then? Well, we'd like this interaction to happen, but we would have to turn a win-lose situation into a win-win situation. We can do this by a value transfer, so it will become beneficial for both sides. And finally, it could be a win-win situation, and we should engage into this interaction, obviously, but we could improve fairness if we want. And so there are 4 social information technology that would support us in these kinds of situations, and one of these is what I call the social mirror. It would support situational or context awareness. The social adapter, maybe a bit awkward word, would facilitate profitable interactions, support us in interactions with others. The social protector would avoid lustful interactions, and social money would incentivize favorable interaction or support value transfer. So this is about self-organizing systems that become possible through real-time information. And then finally, we could also engage into creating collective intelligence. So this is about bringing the best ideas of many minds together. And we don't know a lot about how this needs to be done. So this is really a hot topic. But here is an interesting example. Netflix is offering video on demand, or TV on demand, as you like. And they want to offer their customers interesting movies. Of course, if you're not happy with their services, you might change to somebody else's services. So they're trying to predict the movies that you like based on your own ratings of previously seen movies and ratings of other people who've seen similar movies. And they're not very good at this. Even though this is a big data approach, I think they estimate 10% of predictions of likings on a 5-star system right. And I said, okay, we want to improve this, and it's worth $1 million to us if you can improve this prediction by 10%. 10% is not much, come on, right? And so there were, 1 million is a lot, however, right? So there were hundreds of groups who were engaging into this competition, thousands of solutions that were submitted, and it took more than 2 years. Actually, there was not a single team that managed to win this competition by itself. And then there's this rumor that one day the boss of the winning team has been kind of of the leading team was one day stepping into the office and said to this team, "Come on, shouldn't we maybe do something else again after 2 years?" And then the team leader said, "All right, then maybe we should take another approach." What he said is, let us team up with another team, or 2 other teams even. And as they were the best in this competition, and now they had to team up with 2 teams that were worse, and that didn't have as good solutions as they had themselves. So I would think if you average over the best solution with 2 solutions that are worse, it would produce a worse solution. But I was wrong. I was totally wrong. It was an even better solution. And they won the competition. So what we can say is that in complex optimization problems, diversity wins, and not the best. Only by many teams. Now, each of them would first of all, in a competitive way, try to come up with the best solution. But then we need a cooperation phase where we engage into something together. So, exploration and integration. Okay, so these are all the functionalities that we want to reach. And then the question is, what kind of information system would we need to build to enable all this? And I call this the planetary nervous system. So one day, I woke up and became aware that basically it's in our heads to build such a system, because all it takes is you and your smartphone. Why? Because we can use the sensors in this smartphone. There are about 15 sensors for luminosity, noise, location, whatever. Now, we could use this and connect the smartphones together to build a global measurement network. So, as compared to a big data approach that's collecting all the data that you can get and then finally tries to find some patterns that are there or not, but maybe spurious patterns, here we would create a targeted, a tailored measurement, as we used to do that in physics. In fact, take the elementary particle acceleration at CERN. 99.9% of all the data that are recorded are thrown away immediately because they couldn't be processed anyway. they just keep 0.1% of all data, and they keep that 0.1% that is interesting for a particular kind of experiment. So each experiment makes a different kind of measurement. It's a tailored measurement process, and this is exactly what you would need. And the Internet of Things would enable us to do this. So, for example, we can measure acceleration, x, y, z, and then the question is, what can we do with it? Well, for example, we could detect earthquakes, because if just one smartphone shakes, that has no meaning. But if all our smartphones shake at the same time, then something is fishy here. It would be an earthquake, and it could warn our friends and family members a few hundred kilometers away. It would give them some extra seconds to get into a safe place. So what would we do in case of an earthquake? Well, we care about our survival. In Switzerland, we have these beautiful survival kits over here. The question is, what would be tomorrow's survival kits? And what I did is I organized a hackathon with a number of colleagues in San Francisco. And San Francisco is really threatened by an earthquake. And the question was, what could we do in such a situation? There were about 80, 90 people who signed up for this hackathon, and about 9 or 10 teams that they formed, and 3 of them were the winning teams, and these are the solutions that they created. So first of all, Amigo Cloud. They came up with an app that allows you to take pictures of a destroyed bridge or road or whatever was wrong. You could annotate it, and you could do that of many different places. And as soon as you had connectivity, your smartphone was connected with the web, it would upload all this information. So it would create a map of this environment. If many neighbors do this, then long before emergency units would be in this place, they could already know what has happened there, and all the neighbors too. Now, the question is, would you have internet connectivity? Because basically electricity would most likely be down after an earthquake. So then it's important to have something like an ad hoc network, like FireChat is, for example, enabling smartphones in the future to talk to each other. And we would still need to charge our smartphones, and that could be done with Charge Beacon. So there would be these solar panels that would allow you to charge your smartphone. At the same time, you would get together with people from the neighborhood, and you would have an exchange of information and community spirit and all this kind of thing. And finally, there was Helping Hands. That was another app where you could basically upload information such as, I need some water, I need baby food, I need some help for my grandfather or whatever. And other people could respond and say, okay, I looked what I still have at home, and in fact I have some water left, I have some fuel in reserve, I can provide some clothes or whatever. And so demand and supply would find together locally. So this would enable people to help each other. In this way, it would not only reduce response times, because it often takes 72 hours for disaster response to be fully operational, and these are the critical 3 days. It would free up resources of this disaster response team, so they could focus on these areas that really need help most. And it would create more bandwidth, more capacity, because citizens would engage here. So basically, we have a more participatory system, and that, as we can see, would be much more powerful. Now, when we build this planetary nervous system, we would like to have a system that we can trust. Yeah, it shouldn't just steal data from our smartphones and look at what we're talking and who we're meeting with. And at least I would prefer one that also respects my privacy. And I think such a system can be built in a way that nevertheless supports social order and cooperation. But for us to be able to trust the system, transparency is needed. And control is needed about our information flow. So basically, for each of these sensors, we could say, I want to use it just for myself, the data stream, or I want to share it. And later on, we could also say whom to share it with, for what purpose. And that would require something like an open personal data store, where all the information that happens to be collected about you would be sent. And then you could administer all these data and say, okay, I'm sharing my shopping data with companies because I want to get a personalized product or service. But I'm not sharing my health data with companies. I'm sharing my health data just with my doctor. And my social friendship network, I'm just sharing with my friends. You know, whatever you think is the appropriate sharing of your data, you could control it. And so the idea is to build this planetary nervous system as a citizen web. I mean, all of us would build it together to everyone's benefit. Now, it's important that the state can trust in this system too, right? So how would we reach this? First of all, we would have to think about responsible innovation. We would create coordination tools that have been missing in the past, because social chaos happens when coordination breaks down or is not there in the first place. We would probably restrict free data volume, so it cannot produce much damage. Local interactions, then something like a radar screen that would basically check that there wouldn't be malicious applications, at least not many as compared to the benefits. Large-scale applications would certainly have to be monitored because they could be impactful. We would try to build something like a digital immune system that would block malicious applications. We would try to build something like crowd security approaches and incentive systems to behave in a responsible way. And one of these systems, as I pointed out before, could be reputation systems. And finally, also, merit-based mechanisms could support responsible behavior too. And of course, it seems a good idea to take public institutions on board from the very beginning. So if we do all this, I think we can create a wonderful open data source, a real-time data Wikipedia in a sense. And that would be a participatory system. That means you and I, we could all use it. We could all design it together too. And you can see it's a lot of fun to work on this kind of system, and we can actually use it to create games or turn cities into adventures and many things. Here's just one application. We could come up with something like Minecraft, but using the Internet of Things as input. So the main point here is that it's not going to be an app that, say, my team or whomever's team is creating and restricting your application. It would be as open as possible. So you could combine inputs and outputs as you like. You could create your own games. You could create your own measurement processes and applications. And a funny game is this one, which you could use to solve conflicts. So assume you have different parties at home, and some want to see the love story on TV, and the others want to see the adventures movie, and so you have to take a decision. And here's a virtual arm wrestling that we came up with. So they have to figure it out. And what they're doing is they're using now the accelerometers basically to have a team-wise arm wrestling with each other. You can see Team B was winning. But in principle, you can do similar stuff like conflict resolution games with other sensors, you know? And you could create your own games to solve these kind of problems. Okay, so what are the key components of such a system? A storage engine, local analytics engine, a data broker, a system optimizer, virtual sensors, actuation scheduler, and a global analytics engine. And finally, a routing agent. You'd also like to add a micropayment system. And with this, you could then create your own business. So the board is, as I said, would be an open data stream for everyone. A real-time data stream, a targeted measurement that you can do. And that means you can open a consultancy, you can come up with your own services using these data, you can come up with your own products, in particular if you use 3D printers and other stuff at home. So this is where the jobs will come about. You know, you take the data, you transform it into something useful. You do this. And you could collaborate with others. So based on this idea of prosumer. So why don't we do this together? Build this system jointly, and the principle would be give and take. So basically you can take data, but the system obviously works only if you give your own data back, and some of your data at least, right? If you open some of the sensors. And in the very same way, would we do that for the source codes that are used to measure certain things, or to produce certain kinds of functionality. So people today are very much into sharing of codes, like at GitHub. And again, you could take a code that somebody else has produced, but probably you would not do exactly what you want to do. But you would have an idea what you want to do, and you would sit together with your friends or colleagues and would modify such a source code and adapt it to what you want to do. Then you upload this again to the platform and make it available for others. So in this way, it would produce public benefits. But at the same time, you can also produce private benefits, so there would be a multi-level system, would be this open data stream, there would be premium services, and there would be business applications that are kind of planted into this humus of data and source codes that are being jointly produced. And so that would create something like an ecosystem. Yeah? I use what you produced, I'm modifying it, I'm producing new products and services. That allows other people to come up with new products and services, and so on. So it produces a really highly differentiated information, innovation, and production ecosystem. In fact, there is an interesting study by Barabashi, Hidalgo, Hausmann, and Klinger, and in science, they found that basically the status of an economy very much depends on its differentiation. I mean, how diverse is the product system, the ecosystem. So, yeah, why don't we grow a powerful information and innovation ecosystem together and create new opportunities for everyone, because if we set it up well, this system, then the empowerment of users, customers, and citizens, of us, enables better services, better products, better businesses, better neighborhoods, better cities, and a better world. So this is not a dream. Yeah, we have started to work on this, and you can see a few members of this NervousNet team. And here is just one example application that is used this processor to create a beacon. The beacons are composed of 3 elements, a battery, then this processor, and frame that we have created with a 3D printer, because we want to be as much self-dependent as possible. So this is how we printed it, and then we distributed these beacons in a building. Actually, my team went to this famous Chaos Computer Congress in Hamburg, where there's thousands of computer programmers that go there, and distributed the beacons. And we intentionally didn't use GPS sensors because we didn't want to track people. We didn't want to intrude their privacy, and these are also kind of sensitive people. It could be Secret Service people and hackers, and it's a strange ecosystem in itself. But anyway, so for that reason, we focus only on proximity, not on location. And as a result, we can still see, there are some people, obviously, who are the superstars, where a lot of other people standing around. We can see how that changes over time. So this is just a proof of principle, where we're checking out whether our NervousNet would actually be able to do such a thing. So why don't you get ready, take your smartphone out, team up with your friends and colleagues, and join the NervousNet community. Let us build this together. That's why I'm actually here. I want to build a Singaporean NervousNet hub, and hope there would be one team at least in Singapore that would work together with us and other teams in other cities and countries to build such a public, open, participatory information system for the 21st century. And so if we do this, it could grow global quickly, as OpenStreetMap did. So it started in one city, basically. That was London, and by now it has 1.5 million volunteers and became a global system that everyone likes and enjoys and uses. So thank you very much. I'm waiting for your questions.
Thank you, Dirk.